The room invites you to a challenge where you will investigate a series of traffic data and stop malicious activity under 2 different scenarios. Let's start working with Snort to analyze live and captured traffic. Before joining this room, we suggest completing the Snort room. Note, there are 2 VMs attached to this challenge. Each task has dedicated VMs. You don't need SSH or RDP, the room provides a screen split feature. Use the attached VM to finish this task. Plus, the narrator J&Y Enterprise is one of the top coffee retails in the world. They are known as tech coffee shops and serve millions of coffee lover tech geeks and IT specialists every day. They are famous for specific coffee recipes for the IT community and unique names for these products. Their top 5 recipe names are Wanna White, Zero Sleep, Macdown, Barrakeep and Crypto Y. J&Y's latest recipe, Shot 4J, attracted great attention at the Global Coffee Festival. J&Y officials promised that the product will hit the stores in the coming months. The super secret of this recipe is hidden in a digital safe. Attackers are after this recipe, and J&Y Enterprises are having difficulties protecting their digital assets. Last week, they received multiple attacks and decided to work with you to help them improve their security level and protect their recipe secrets. This is your assistant JAVA, just another virtual assistant. She is an AI-driven virtual assistant and will help you notice possible anomalies. Hey, wait, something is happening. Plus, JAVA. Welcome, sir. I am sorry for the interruption. It is an emergency. Somebody is knocking on the door. Plus, you knocking on the door. What do you mean by knocking on the door? Plus, JAVA. We have a brute force attack, sir. Plus, the narrator, this is not a comic book. Would you mind going and checking what's going on? Please. Plus, JAVA. Sir, you need to observe the traffic with Snort and identify the anomaly first. Then you can create a rule to stop the brute force attack. Good luck. First of all, start Snort in sniffer mode and try to figure out the attack source, service and port. Then, write an IPS rule and run Snort in IPS mode to stop the brute force attack. Once you stop the attack properly, you will have the flag on the desktop. Here are a few points to remember: create the rule and test it with a console mode. Use a full mode and the default log path to stop the attack. Write the correct rule and run the Snort in IPS a full mode. Block the traffic at least for a minute and then the flag file will appear on your desktop. Stop the attack and get the flag, which will appear on your desktop.
Challenge live attacks. In this video, we're going to apply what we learned in a previous video. So if you want, before doing this room or before following up with me in this video, I recommend you guys to watch my video on Snort IDS IPS Complete Practical Guide. This video walks you through how to use Snort and how to set up Snort in all the modes: sniffer, packet logger, and IDS/IPS. In this room, we're going to take what we learned here and apply it in this scenario. So we have 2 scenarios. The first scenario is we have a brute force attack. We have to find out about this brute force attack, detect it, and block it using Snort. And the next scenario is we have to discover or find the presence of a connection attempt using reverse shell. And we have to find, also we have to block it and answer the questions. So you can read through the scenarios here, but it's very easy, very simple to understand and grasp. You have an endpoint. Your endpoint is actually undergoing a brute force attack. We have to find out what is the port, what is the protocol under attack, and then extract the flag. So basically, there are several steps you have to take before grasping the flag or taking the flag. The first thing, we have to start Snort in sniffer mode. Okay, let's Snort sniffs the packets. Okay, then it will log everything it has sniffed in one file. We're going to investigate the file, find out what the port, the protocol under attack, and then we're going to create a rule, okay, to block the attack. After creating the rule, we will start Snort in IPS mode. The same with this reverse shell. So the first key thing to do all the time is to start Snort in sniffer mode. So after you start the machine, you will split the view here. The same with the next one. Every task has its own independent machine, so you won't need to, all you have to do is just to switch between them. So don't start them together one by one. So this is the first one. We're gonna view in full screen, and now the assumption now is that this machine is actually undergoing a brute force attack. So basically, there's a brute force attack on one of the ports. As you can see, there is an alert here. Your machine is under a brute force attack. In reality, you won't get this kind of alerts. View in full screen, and now the assumption now is that this machine is actually undergoing a brute force attack. So basically, there's a brute force attack on one of the ports. As you can see, there is an alert here. Your machine is under a brute force attack. In reality, you won't get this kind of alerts. Okay, it's just because of how the machine has been configured. You know that there is a brute force attack. You're gonna start Snort in sniffer mode. So there are two modes. First, sniffer, it will display the packets in the output, or you have the logger mode. It will sniff the packets and log them. So basically, for this tutorial, I selected the logger mode. So on the sheet here that I am sharing under this channel membership only, I will just run it in logger mode. So I'm going to explain the command. So what happens here, that I enable the logger mode and I define the directory to where I will save the log file. I will run this, leave this running for a while, giving it a chance to capture the traffic. Hopefully it will capture the brute force attempts. Okay, one more 5 seconds. 1, 2, 3, 4. The more you wait, the better. The more accurate the data that you will get. So basically, don't rush things. Okay, I'm gonna stop this now and take a look. So I have one log file here. I'm gonna have to read the log file using sudo snort-r and define the log file. Enter. So now I see all of the packets. In total, I have 12,776 packets. So before, that's the methodology. First, we run Snort in sniffer mode. We capture the packets. Then we have to actually answer the questions, find out what is the port and the protocol under attack. So the order of the question may be telling you that you have to find the flag first and answer the rest of the questions, but in reality, it's better to answer them the second and the third and then the first question, because it follows the order of how things work. So first we start Snort in sniffer mode, we log the packets, and then we have to analyze the packets now. When we analyze the packets, we will extract the answers for 1 and 2. Okay. Afterwards, we will start Snort in IPS mode, and after starting the Snort in IPS mode, you will have the flag. Okay. So do it like that. It will be better for your working methodology. Okay, let's analyze now the file. So we are being asked to find out what is the port and the protocol under attack. So as you can see, this is the machine. This is the as you can see, let's find out first the IP address of the machine. Good to know the IP address if config. So we are 10.234.0.1. Do we have other addresses? This is for the Ethernet 1. For Ethernet 0, we have 10.10.11.123. Let's see what this IP address here. Okay, so this is our IP address. As you can see, we have several connection attempts to our IP address on port 80. Now, in reality, it could be someone trying to brute force a login form or HTTP basic authentication. It could be, by the way. So it's actually, it stands as a probability now. Now let's scroll up. See this one? Now this one actually originates from my machine. I don't want, we have to skip all the connections or of the packets originating from the machine. We are interested in inbound traffic only. Inbound meaning that this IP address has to be always after the arrow here, meaning that it's receiving traffic. So let's say we have port 80 and we've also port 22 for SSH, right? Scroll up. We have several other ports, random ports, but most of the traffic coming to port 80 and port 22 as I can see here. Okay, maybe the machine that is receiving the SSH traffic is not actually our machine, but it is definitely on the same network, judging by the IP address. So, okay, so now we have a pattern now of port 80 and port 22. Let's filter the traffic now. Port 22, see how many packets. So we have 1,505 packets for 22, and for port 80, we have around 22, and for port 80, we have around, this is like we have way more HTTP packets. We have around 100,000. Oh my goodness, we have too many HTTP traffic. All right, so let's get back now to the port 22 and study the pattern here. Scroll up. Okay, so what do we have now? As you can see, if we scroll up at the very first, or let's read the first 10 packets. Now it's -10 -n10. Okay. Yes, I'm skipping the, wait. So 10 packets, 10, 10, 10. Wait, these are more than 10. Okay, so from here. All right, so we have a connection attempt from inside our network. and then this one is replying back. Okay, we're looking for, yeah, so as you can see, look at this IP address. So this is, scroll up. Okay, this one is an IP address inside the network, as I can see from the subnet here, and this one outside the subnet. So we see these two IP addresses, as you can see, this one here and this one here, they are both exchanging the roles, source and destination, every time. So we have one connection attempt from this one to this one, and then back from this one to this one, and like so. So this means that there could be some attempt to log in, right? You won't find that number of SSH packets in one session. So let's now view all the packets. So we have 1505, and if we take a look at all the packets, we see the same IP addresses all the time, the same IP addresses. Now it could be that someone is interacting with the SSH server, but not that long, and not in that repeated pattern. So if you look now at the port 80, let's rule out port 80 now. So you have 11,253. So the pattern for port 80 is like that. So do we have repeated IP addresses? Let's take a look. Yeah, so as you can see, this IP address is continuously shown to be browsing to this destination, which is our machine on port 80, continuously repeated. This could be actually explained as a browsing, right? It's browsing the web server and installed on this machine. But the previous one, there was some interaction, right? So in order to brute force, you have to send your password and username, and then they get the feedback from the server, right? It's the same pattern we found when we looked at the SSH traffic. So it's safe to say here that the brute force attempt was being conducted against the SSH port. So it's this is the service under attack, and the protocol is TCP, and the port is 22. Now it's time to grab the flag. After we have analyzed the logs and now we understand what's happening, we can now create a rule to block the attempt. So sudo nano etc snort rules local.rules etc snort rules local.rules. Rules, and here we write our rule. So in Snort we have three kind of rules: log, alert, and drop. So in the scenario here, we're being tasked with dropping the packets. So we will start with drop. Define the protocol TCP. Since the attempts are inbound coming to the network, we're gonna have to block them in the other direction, which means we're going to select any IP address on the network and on the port 22. Okay, the direction will be like that. So this means the traffic is coming towards my network, inbound, and from any destination, okay, on any port. And let's write a description. So we're gonna have to go to some example rules. It's quicker to just grab a template like that. Okay, paste, and now we're gonna say here SSH brute force. It's fine with the rest. So what's gonna happen here that it will drop all the packets, okay, coming from any IP address on any port to exactly any IP address on my network, and specifically on port 22. Let's see if this will work. And then we will start Snort in IPS mode. So let me see where I can find the command. You know, you cannot memorize commands, so let's see where it is. IPS mode, in full mode, by the way. Okay, this is it. Now this one in console mode, I'm gonna have to modify the last word. Okay. Full. Now once you start this, when you start Snort in IPS mode, in 1 minute you should receive the flag here on the desktop. Let's see. So what do we have? We have error here. Illegal direction specifier. It just means we cannot use this direction, I guess. We're gonna use the bidirectional. So bidirectional means inbound and outbound. Okay. All right, now in 1 minute, we should receive the flag here on the desktop. Okay, while this is running, let's use inbound and outbound. Right, now in 1 minute, we should receive the flag here on the desktop. Okay, while this is running, let's now jump to the next task. Now, the next task, we are being actually asked to find out if a reversal is being used inside our network, which means we are assuming that a machine in shell is being used inside our. Okay, while this is running, let's now jump to the next task. Now the next task, we are being actually asked to find out if a reverse shell is being used inside our network, which means we are assuming that a machine inside our network has been compromised. Hence, the machine actually is communicating with the attacker using the reverse shell. So you have to find out. So in this scenario, the traffic direction is outbound, coming out of the network. Okay, so I think we have found the flag, and here it is. Copy it and paste it. So it's done. We are done with this machine. We're gonna stop this machine and start the reverse shell. It's good, guys, if you give this a read through, understand specifically the scenario, but it's very easy, guys. Just have to follow the same steps we followed in the task 2. We're gonna start Snort now in sniffer mode or logger mode, whatever you want. After we understand the pattern appearing in the traffic, after we analyze the traffic, then we'll be able to come with answers for the what is the port and what is the protocol. After analyzing these and armed with the information, we're going to create a rule to block these on our network, so the attacker won't be able to use the reverse shell. Technically, we are actually blocking the attacker's ability to communicate with the machine, but it doesn't mean that we actually have cleaned the machine. This is another step in the instant response. Now your job is to analyze the traffic and create a rule to block the malicious traffic. Okay, so we started viewing full screen, and as before, we're assuming that the machine is under attack or the network is under attack, spawning up Snort or the command line and starting Snort in -L in logger mode. Okay, sudo. Okay, right now we are sniffing packets. Now sometimes you have to define the interface. If you're running more than 2 or 3 interfaces, it's always good to define an interface through which the traffic is being traversed, so you have to define this. But since here we're using only one interface, we didn't define that. It's by default Ethernet 0. Okay, we're giving this some time until it captures the traffic. Okay, enough. ls, so we have captured 10,327.
Use the attached VM to finish this task. Plus, the narrator, good job. Glad to have you in the team. Plus, JAVA. Congratulations, sir. It is inspiring watching you work. Plus, you thanks team. JAVA, can you do a quick scan for me? We haven't investigated the outbound traffic yet. Plus, JAVA. Yes, sir. Outbound traffic investigation has begun. Plus, the narrator, the outbound traffic. Why? Plus, we have stopped some inbound access attempts, so we didn't let the bad guys get in. How about the bad guys who are already inside? Also, no need to mention the insider risks, huh? The dwell time is still around 1 to 3 months, and I am quite new here, so it is worth checking the outgoing traffic as well. Plus, JAVA. Sir, persistent outbound traffic is detected. possibly a reverse shell. Plus, you got it. Plus, JAVA. Sir, you need to observe the traffic with Snort and identify the anomaly first. Then you can create a rule to stop the reverse shell. Good luck. First of all, start Snort in sniffer mode and try to figure out the attack source, service and port. Then, write an IPS rule and run Snort in IPS mode to stop the brute force attack. Once you stop the attack properly, you will have the flag on the desktop. Here are a few points to remember: create the rule and test it with a console mode. Use a full mode and the default log path to stop the attack. Write the correct rule and run the Snort in IPS a full mode. Block the traffic at least for a minute and then the flag file will appear on your desktop. Stop the attack and get the flag, which will appear on your desktop.
ls okay, sudo snort-r to read the log file, and yeah, okay. As always, let's pick up a couple packets here to understand the pattern, and then we will filter out. So let's take a look at this. First, let's see the IP address of the machine, because we have to find out the direction of the traffic. So we are 10.10.72.197. Let's see where I am here. Okay, here it is. This is my IP address, and this one is on port 80. So there's someone browsing the web server here, no problem. Another pattern here. Take a look at this packet. So this packet actually is initiating a connection from this IP address using port 44s. This port is very known actually to be used as a listener, right, for reverse shells. So I'm gonna take a note of that. Now, so IP address ends with 55 and one ends with 156. Take a look at this one. So this packet actually has the same IP addresses. One ends with 55 and the one ends with 156. But now the direction is the opposite of this one. So this one actually is coming kind of inbound to this IP address, and here we have the IP address here ends with 555 responding to this IP address ends with 56 on the port 444. So meaning that this port, okay, or this IP address has a program running on port 44s and is interacting with this IP address continuously. Let's see other packets. Take a look at this one. The same pattern. We go up, also the same pattern. Now, who is this IP address? Not us, some IP address on the network. Scroll up, take a look at this packet here. Yeah, the same. A program with port 444s running on the IP address ends with 156 and is continuously being actually hit with packets from this IP address. This could be actually translated and explained as this IP address is actually, interacting and sending out some commands to execute on this IP address. Of course, this if we assumed that this program is running on a reverse shell or running a reverse shell on this port. Now, this port is very well known to be used when creating reverse shells. If you want the proof, we can see here port 4444. And as you can see, immediately we have queries popping out for Metasploit, exploit, used for. Let's take a look at used for. Let's be realistic here. Okay, so some rootkit, according to Cloud Savvy Kit, backdoor and Trojan horse software opens and uses port 444s. It uses this port to eavesdrop on traffic and communications for its own communications and to exfiltrate data from the compromised computer. Okay, so it's very safe to answer that the protocol is TCP and the port is for fours. Which tool is highly associated is Metasploit. Why Metasploit? Because when you actually use the listener on Metasploit, the options by default shows that or come pre-configured with the port as 444s and the host is the L host. So that's why we answered the question with Metasploit as the answer. Now it's time to grab the flag. To grab the flag, first we have to create a rule to block these packets. So sudo nano etc snort rules local rules. Okay, so first drop TCP. Now since we don't have specifications about the IP addresses, I know we saw some IP addresses, but now let's drop the traffic, drop the packets on any IP address, right? Because sometimes you have more than one host that's compromised, so you have to block the communications on a broader level. So the direction here is outbound, meaning that it's coming off the network, our network, which means we're gonna have to say from any IP address. Okay, now on the port 4444, the direction will be outbound like that to any IP address on any port. Let's see if this works. And now let's grab some example message from here. Let's take this one. And now here we're gonna type reverse shell port found. Okay. Okay. Now we run Snort in IPS mode. Again, we're gonna change the last word from cancel to full. Hopefully this will work and this will make the flag pop up in the desktop. Let's see. Now if this doesn't work, okay, we may need to change the direction of the traffic from outbound to be bidirectional. I'm gonna assume, it worked. Okay, it worked. So this means that we actually configured the right traffic direction. Okay, this is the flag. And now guys, you have the full solution for this room. I hope you guys like that, like the video, and definitely I will see you in the next video. There is one interesting room that has been launched today. It is Snort Challenge the Basics. So we may be doing this room for the next video.